Dr. K. Tamilmani is distinguished scientist. He is presently Chief Executive of Center for Military Airborne Certification, that is called CEMILAC, which is in Defense Research and Development Organization. He has done his degree in aeronautical engineering at MIT Chennai, post-graduation as BITS Ranchi, MA Defense Studies at Madras, MBA HRD at IGNOU, and he has conferred with doctoral degree in Defense and Strategic Studies by the University of Madras this year. The subject of his research was military technology dynamics and its implications on national security. As Chief Executive, I'm not giving all details.
Almost everybody knows now.
And one more thing, he is the organizing chairman of this seminar, and this is the second time he is organizing as chairman. So now I hope people will be appreciating all these lectures. Please hear.
Thank you.
I request chairman to introduce.
In addition to what he said that I organize, and I have another mandate is to chair the session when the chairman is not available. Dr. Christopher, for some commitment, he has to go, but he is well represented by his team to answer any questions which Katarki cannot answer. Okay. So now let us talk along with the first lecture will be by Katarki, and he is the old friend of mine, colleague of mine. We worked together probably for 25 years plus, and we all know he's been with the DRDO for quite some time. And I request now he is leading the current indigenous program of AEW&C. I request Katarki now initiate your presentation. Come.
Good morning. First of all, at the outset, I thank the chair for such a generous introduction and unconventional one. Thank you, sir. Fellow speakers, ladies and gentlemen, when we started into this endeavor of making India's own AEW&C program, it was very clear to us that it's a very complex system, and all the wherewithal that is needed may not be available in CAPS. We need to network, we need to collaborate, and we need to seek cooperation from wherever it is available. With that outlook in mind, we started off. The fields of cooperation were not necessarily for design and development. They were also from experimental as well as theoretical analytical studies, whether it was a technical reviews or in case of AEW&C, a very software-intensive system. So we sought cooperation even in IV and V. So with that, we took off, and the first thing we had to decide was the platform, flying platform for this system. Fortunately for us, our networking and cooperation with the Air Force, we could zero on to Embraer 145, EMB 145 platform, which was already modified and flying with 3 other countries. So that made our life very easy, and the takeoff was very smooth. So without much ado, what I intend doing in this next 30 minutes or so is to cover very quickly how the AEW or the AEW&C or the AWACS have evolved over the years, how the AESA radar came into picture, and take a very quick look at the systems that are available today, and move on to our AEW&C, Indian AEW&C program, where we stand, where all we networked, and what are the lessons learned. The real AEW&C program started probably operationally feasible one, started with the E2 Hawkeye, everyone knows it. That was followed by the E3 AWACS of the Americans. Both employed the mechanically rotating antenna primary radar and IFI back to back. And very soon, we saw the advent of active electronically scanned array, that the AESA, and Indian Air Force is already inducted the IL-76 from ELTA. The arrival of AESA radars, which basically consist of, for each element of the array is fed by its own transmitter and receiver and a common phase shifter, lends itself a few operational as well as technical advantages. I'm sure that the Augusta gathering like this is quite aware of the capabilities of AESA radar. It could be graceful degradation in performance. It could be very electronically agile beam, which permits you to not only do the track file scan, but go in for high precision tracking, full track mode, and the updates of measurements that you would gather from the radar could be at your disposal. So it has better ECCM features, so I'll not go into all those. So this brought in a kind of change in the scene of AEW and AWACS the world over. These are the currently AESA-based 5 systems. We'll have a quick look at each one of them. The first one in the AEW or AWACS scene was the Swedish ARJ radar on Saab 140. It employed 2 arrays in a rectangular pod-like structure on the top of the aircraft. It was a propeller-driven. It was a S-band radar giving 120 degrees on the either side, that is 240 on the. So there was a considerable amount of blockages in the fore and aft axis of the aircraft. Second one, the same ARJ was adopted by the Embraers, and this particular system is available with Brazil, Greece, and Mexico. The other one, Westtail, Boeing's offering to the Australian Air Force, Royal Air Force. It employs the MESA radar of Northrop Grumman. It has a T-structure dorsal unit on the top. The side panels in L-band provide the 240-degree coverage, and the top hat provides the other fore and aft coverage. Of course, the ELTA is here. Maybe he will talk more about it. The lack of coverage in the fore and aft axis is covered by the S-band arrays in the front and the back of the radar on a G550 platform, and our own Indian Air Force AWACS, which covers 360 degrees. Just to bring home the point to many of the people who may not be very aware of this, a 240-degree coverage looks like something what is depicted here in the blue color. When you go for anything like a limited aperture for the fore and aft, you end up with a coverage which is less than what is on the either side. The percentage could range, it could be anybody's guess. But however, if you use 3 panels, each covering 120 degrees, and put them in a dome, this gives you equal coverage all through the 360 degrees. Incidentally, keeping in with the theme of this seminar, even here, India, Israel, and Russia were in collaboration and networking to produce this product. Now, with this introduction, I come down to our own system. The operational roles that the Air Force envisaged for this was to detect, track, and do the command and control function and act as a complement to the bigger IL-based system. AEW is not new to CAPS. way back in 90s, we had mounted a mechanically rotating rototome-based radar on the top of Avro HS748. And many of you who are old-timers would know that it came to an unfortunate end. From there, keeping in with the trend of the world, we have also switched over to the electronically scanned AEW&C based on Embraer 145 and using a rectangular port on the top in S-band. I have covered this, and how does this stand in comparison with a contemporary and comparable system? Well, you have, am I audible? No. Okay, doesn't matter. We have a primary radar like the rest of the Embraer-based platforms have. We have added elevation scan just to overcome the aircraft banking problems. Of course, it is limited to certain, maybe around 7 to 10 degrees of aircraft bank. We have a IFF system like all others. Now, the IFF happens to be Mark 12 with the S mode capability. We have a wide 360-degree coverage ESM. We have a CSM plus CSM recording for offline analysis. We have a C-band data link for line of sight air-to-ground and ground-to-air data link capabilities, which is a high-capacity one. Beyond the line of sight, we use SATCOM of similar capacity. We have 7 VUHF set, 5 for the crew and 5 for the 2 for the. In addition to the cockpit-based VHF set, we have provided 2 more to the flight crew. And that provides data and voice. This is in keeping with extending the network-centric operation right up to the fighters or our own interceptors. We have catering for 5 operator workstations, the consoles, which forms the eyes and the ears of the system for the operator on board. We have an in-flight refueling system to extend the time on station for this kind of strategic system. The moment you go for an in-flight refueling, you need to carry additional crew members, and that's how the additional seats also have been catered for. So these are the major differences that I would like to keep in mind, and the capabilities that we intend to put, and so far, how far we have come in implementing this. Let's have a look at that. Who are our partners? The Active Array antenna unit, AAAU, what we call, is the dorsal one, is the design and development is undertaken by CAPS, Center for Airborne Systems. We are the nodal agency for this program. Rest of the subsystems of the primary radar comes from LRD Bangalore, that is Electronic Research and Development Establishment. IFF is done by CAPS, and ESM is from the DARE, that is Defense Avionics Research Establishment, Bangalore. Communication support measure comes from Defense Electronics and Research Laboratory, Hyderabad. So these form the 4 major sensors of the AEW&C system of India. We have, this is the mission system controller, in other words, is the mission computer, which is the heart of the nerve center for the computing. It carries out all the integration of all the sensor data, establish the system-wide tracks, carry out the threat assessment, provide the control and guidance, intercept vectoring and recovery, and host of housekeeping duties. Data handling system, display system consists of 5 OWS. All the communication is over the Ethernet. Plus, we have a self-protection suite from DARE, which consists of RWR, missile approach warning, and a countermeasure dispensing system, that is flares and chaffs. These are our development partners, and each one of the work center has their own OEMs, their own interactions with their vendors, as well as the cost suppliers. Now, let's have a look at how we interact with Embraer, and because that forms the major portion of the development work, as well as the financially also. Both Embraer and CAPS have entered into the contract in 2008. Concurrently, CAPS interacts with all its work centers, including the Air Force team, which is positioned at CAPS, plus the certifying agency, CEMILAC, and DGAQA, inspecting authority. We work out all the budget because remember it's the airborne platform, constraints are there, so the budget for weight, power, cooling, space, everything needs to be worked out, and for this you have to leverage all your networking capabilities as well as mutual cooperation and examine what if and sensitive analysis before we arrive at any final figures. After this, we have to give a approved ICD, set of interface control documents, to Embraer, against which the modification of the aircraft will be carried out. They in turn have their own OEMs, their own certifying agency, and their own government. So that's how the linkages are established under two clusters, one in Brazil, one in India. The platform, Embraer EMB-145, is a 24-ton class MTOW platform. It's a modern platform with good serviceability and availability figures. And this platform, along with the AAAU on the top, is going to be certified to FAR 25 requirements by Embraer. So that's the collaboration we got into with Embraer to take away a major portion of the, take advantage of the modifications earlier done and leverage that for our program. Of course, the modifications are to our requirement. We'll quickly take a look at it, what we did for the modifications. So even though the green aircraft is coming from Embraer, it's actually born against our requirements. These are the major structural changes. Obviously, the pylon assembly and the structural reinforcement that is needed has been incorporated. There's a SATCOM dome sitting there, the in-flight refueling. The platform originally had only one APU. We wanted another, so this platform comes with two APUs now. It had two cooling packs. Because of our higher payload and electronics packages available, we needed a third package. And above all, we added to the basic aircraft 59 antenna. Now you can well imagine the kind of interaction that will go into if you have to mount on a small platform like this additional 59 antennae with their problems of field of view, electromagnetic compatibility, and mutual interference. And you can very well gauge the kind of global networking that needs to be done to get this going. Similarly, the in-flight refueling, the IF refueler happens to be the IL-78 based one. It's a 4-engined aircraft. This aircraft needs to go behind it in its huge wake and mate successfully and get refueled. So these are the major modifications which have been done, and various working groups working on this have interacted both technically and managerially to get this going. Similarly, a view of the cabin layout. We have the mission system racks in the front. This is the fore and this is the aft of the aircraft. These are the mission system racks, followed by 5 operator workstations, 5 crew seats. Then we have some storage facility, and we have added auxiliary fuselage fuel tanks to increase the endurance of the aircraft. This calls for working in close relation with the Embraer for weight and balance, CG balancing of these. Although Embraer was to certified for against FAR requirements and look after the handling capabilities of this air platform, we as the designer of AAAU were to have inputs on the aerodynamical as well as inertial loads coming on to the dorsal unit at different alpha and beta angles. So we ran our own wind tunnel campaign both at low speed and at high speed in at Indian Institute of Science Bangalore and NAL Bangalore for including the flow visualization to arrive at the load, and that formed the basis for on which we worked our structural aspects of the AAAU. So ISC as well as NAL were leveraged for the wind tunnel as well as the stress analysis, CFD studies. You can see the airflow depiction of the TR modules, the RAM air being taken and being circulated to cool the electronics within the AAAU. Now I quickly come, this is halfway through my talk, so far I'm maintaining the timing. So the prima donna of AEW happens to be the primary radar, and most of my time will be on this, because the platform aspects you have already seen. Making of the AAAU was not a simple thing. It is a multidisciplinary in nature, starting with aerodynamics, mechanical, environmental, electrical, material and fabrication, and of course the electronics. So there was an interaction amongst all this design group to arrive at a viable AAAU which a 24-ton aircraft can take, at the same time give a radar performance which matches or at least exceeds to a certain extent to what is available contemporary. Probably we can discuss who are interested in knowing, but that particular slide was to depict the kind of networking that was needed at CAPS to go achieve success in this field. This shows the miles of RF cables that are being routed from the TR modules to the radiating elements. The AAAU itself consists of, this is the front of the AAAU. There is there are two ducts running through the entire length of 8.24 meter long dorsal unit. One carries the RAM air, the other one takes away the hot air from it. The primary radar and the IFF radar panels you can see. This one is the primary radar S-band array. This is the L-band array of the IFF. And you can see the 8 elements in elevation to provide the elevation scanning. And it is now mounted for one of the structural tests, which I will cover soon. This is the GVT and the modal analysis that was carried out. And the interaction that went through the panels, the antenna panels, instead of having a regular radome, we took a different path. Teflon, not exactly Teflon, a material based on Teflon was fabricated, and they are cladded onto the antenna panel to protect it against the weather and other conditions. So this kind of structure, CAPS, ISRO helped us to put this cladding. Taneja Aerospace, Structural Engineering Research Center of CSIR, Bharat Earth Movers Limited, and GTRE were in network. They were collaborating under the aegis of CAPS to do the wind tunnel, not only the wind tunnel, the bird impact study. You can see the bird impact studies done on the panel, and it is qualified. Same test was done on the front hood as at different beta angles and the cruise velocity of the aircraft. One of the important building block of any AESA happens to be the transmit-receive module, which consists basically of a low-noise, high-power amplifier and a low-noise receiver. So each one of them feed every element of the array. And this is something which is prone for denial and is not easily available. And if we have to do it within India, we have to produce it, qualify it for airworthiness, and it needs to be air-cooled, and quality system and production in numbers, in hundreds, has to be established. I'm glad that we have been able to do it and establish this with the help of Astra Microwave at Hyderabad. And this shows the inside view of the TR module. The cooling of the AAAU is also depicted here. When we did this analysis, the power supply units were housed inside the bottom duct. We had to open a bypass to cool them. And like all other avionics major system, it had to undergo lightning tests, both for direct effects and indirect effect, that is high voltage and high current. You see a truncated model, 2-segment DOU under lightning test. This facility is in CAPS. Now you see the truncated version, dual segment AESA being mounted and under anechoic chamber. On the top of the LRD facility, that is 100 feet tower, undergoing radiation trials. This is a full-fledged 8.24 meter long full array in the PNFM facility, planar near field measurement facility of CAPS. And the collimation and calibration of the TR module and the array is over. Some of the results of the collimation and calibration are shown here. And this has been integrated and tested with opportune targets and simulated targets as well, and some of the results of the tracking are shown here. Now I'm coming to the second major sensor that happens to be IFF. This is a Mark 12 that is with the mode 4 and mode S, level 2 interrogator, developed in-house. Of course, the high power L-band amplifier comes from elsewhere. Since we didn't have a platform of Embraer available straight away, Aero aircraft, which is available in CAPS as a flying test bed, we utilize this to test our individual system, not in an integrated mode, but as a standalone facility. That's why a special planar array was made to implement the electronic scanning of the IFF beam. It was put through the rooftop trials. It has been fitted on the Aero. You will see the antenna array here. Flight trials have been done in 2 phases. The third phase is due now. We have been able to establish all the modes of operation, 1, 2, 3A, C, and mode 4 S is pending. What we have achieved are the range, azimuth accuracy, scan time, and coverage time. That's the test report. The ESM system is done by DARE in Bangalore. This shows the picture under integration in the lab condition. The ESM, as I said, is capable of covering 360 degrees. It's capable of giving high accuracy in frequency resolution as well as direction of arrival. Similar words go for the communication support measure of DLRL Hyderabad. It has a scanned DF plus a recording device to do an offline analysis on the recorded CSM data. This shows the manifold studies of the CSM antenna being carried out on the rooftop of CAPS. The mission communication system consisting of 7 VHF sets plus the audio management system under integration in the lab. Now coming to the mission system controller, which is the nerve center who basically acts as the mission computer for us and literally orders who talks to whom, when, what, and why. So this shows the mission system controller in the lab integrated environment. This particular system is software intensive, and since Air Force were still evolving their concepts of battle management and command and control, the Air Force team in CAPS is totally involved in developing this and the algorithms, the intercept and control algorithm based on collision, pursuit, collision and offset have been developed, and they are under validation, and the Air Force team with the full-fledged fighter controllers evaluate these algorithms and give us a go-ahead. The software is being built in 3-4 builds with added functionality as we go through. So we validate these functions through an IV and V team which is positioned in CAPS. These are the 5 OWS integrated in a fuselage-like structure. The data link and the SATCOM terminals, you can see the ground counterpart of them. We have a AEW&C system simulator also, just to verify the design, evaluate the performance, and validate the algorithms that we have used. One of the scenarios depicted. As I said, that there are so many antenna on this, maybe 70 odd. The EMI EMC issues can break or make this program. And we had no other choice other than establishing a full-fledged EMI EMC facility to ensure that the aircraft qualifies through this. And we are working very closely with Semilac because Embraer is responsible for structural integrity, whereas a functional certification will be given by Semilac. Making the AEW system alone is not sufficient. Any such system requires ground support systems. The first one happens to be the mission planning and analysis system. This is the view that has been developed in CAPS. It prepares the pre-mission data for loading onto the mission computer of the AEW system. Similarly, it takes on the recorded data, and one can do analysis on the ground. Since we have to do rooftop radiation, some basic infrastructure has been created. The AEW&C system talks to the ground exploitation station, 3 of them, deployed at the criteria laid down by Air Force, and it needs to provide both data link as well as VHF channels, plus 2 OWS for the ground commander to exercise his control. These are also part of the deliverables of the program. And our old flying bird, I'm very fond of it because literally I started my career with this. It shows we use this platform for all our standalone testing and flight evaluation, because Embraer platform is likely to come in the later half of this year, and we don't want to lose the time, because the time schedules of this program happen to be extremely ambitious and very tight, and we need to prove them as quickly as possible. So that is the approach we have taken. And all the flight testing is done by ASTE, the Air Force unit, which undertakes all the flight evaluation here. And the physical, electrical, functional integration rig on the ground is available at CAPS. in a condition or environment as close to the aircraft as possible using the same cable looms. And this is one such picture depicting evaluation of the system at the OWS. This shows the fuselage junction. By now, all the 3 fuselage junctions of the 3 aircrafts are over in Brazil. And the first AAAU was handed over to the Embraer team in December, and the rollout of this aircraft is scheduled as of today on 21st February in Brazil. And what we intend carrying on with our networking, Embraer has finished the fuselage junction, pylons are available, they fit the AAAU, roll out, carry out the flight test campaign with the AAAU that we are given, which is a dummy in the sense of the mass equivalent and CG equivalent. In the meanwhile, our full-fledged AAAU is getting ready with the electronics in it. It gets evaluated on the rooftop. We have no means of fitting it on the Aero. So once the aircraft comes to India, we need to swap the actual AAAU with the dummy and carry on our flight evaluation. So this is the networking approach that we have undertaken, and all our aspirations and proof of the pudding will be seen in 2012 when we get about 1 year plus to integrate the subsystems onto the platform, which is coming this year, later half, and we hope to go in for IOC in 2012. And I want to acknowledge all the help that I got from Center for Airborne Systems and DRDO, and in particular Dr. S. Christopher, the Program Director and Director of CAPS. Thank you. If you have any questions.
Thanks, Kurtz. I think 1 or 2 questions we'll take now. Any questions? Upgrade man.
And what I would like to know is, what is the isolation you get between 2 antennas? To my knowledge, even if you have one extreme, 2 antennas in Aero, we did, it's around 20 dB. So either, because of proximity of the antennas, this, the 2 you have some 59 antennas in total. So what is the isolation you get? And then how did you have the EMMC, this one? Is it through frequency management or this one?
We have a very extensive study taken on this. First one happens to establish the field of view of each one. It's not only the antenna, the MOS sensor, the RWR, and so many other host of other things are there. Then establish the field strength, measurement of the field strength, using FEM technique, simulation of this. I'm no expert in this, but what has been done in the program I can narrate to you. But if you followed by some simulation exercises have gone through, which you are very well aware that the software packages which are available now using different techniques, that has been done. And some, just to establish the validity of the models that we have done, we are using some experimental studies. One of the things I showed you was the CSM antenna manifold study, just to check what we assumed in the simulation, is it right or not. But if you ask me the dB levels, I'm sorry, I mean, I may have to consult my colleagues here.
Yeah, no problem. We'll cross the runway and come and see your reports.
Okay, thank you. And one more question on this, sir, just a minute. For the radome, what you have used in this one, does it cover both the bands of, L band and S band?
It covers both L and S band.
And
it sustains all the vagaries of the weather and airworthiness requirement, and being very close to the radiation surface, that aspect also has been.
What are the tests have been carried out on the radome? I would like to know this.
It is not radome per se. if you are asking how we have qualified electromagnetic test or structural test, let's get back.
Both. I just want to know that.
As far as the structural test is concerned, is part and parcel of the triple whatever it undergoes will go through. As far as the Teflon cladding is concerned, samples have been put through to find out all the dielectric material strengths and all that.
That is on the structural aspects of it.
Yeah, listen. All these 200 people will curse you because will be getting delayed for lunch.
Okay, sir. Thank you. Okay,
you can have all your discussions either during lunchtime or take an appointment with the Katarki. He is available about 200 meters away. All these clarification test schedules will be provided even in Similac also. No problem. Thanks, Kats.
Thank you.
It's a wonderful job done. It is one program on schedule. I am sure that 2012 it will be his IOC, and as usual I will be handing on IOC clearance similar to what we did for Tejas.